Did you know that there's a type of beetle called a bombardier beetle? It can squirt nearly boiling water from its abdomen to deter predators. That is freaking crazy, right? Let's work out the thermochemistry of this neat trick and find out about the enthalpy of a reaction. If we mix hydroquinone and hydrogen peroxide, just like the bombardier beetle does in its belly, we get quinone and water. If we do this in a calorimeter, we can actually measure the heat released by this reaction. So let's take 50.0 milliliters of 0.250 molar aqueous hydroquinone at 24 degrees Celsius. Let's mix it with 50.0 milliliters of 0.250 molar hydrogen peroxide at the same temperature in a calorimeter. We find that the temperature of the solution increases, reaching a high of 30.2 degrees Celsius. This reaction gives off energy, which is absorbed by the surroundings, causing their temperature to increase. The energy absorbed by the solution mixture can be calculated using the equation Q is equal to M times C times delta T. We have 50.0 milliliters plus 50.0 milliliters, which equals 100 milliliters of solution. Aqueous solutions have a density of about 1 grams per milliliter. So the mass of the solution is approximately 100 grams. C is the specific heat of the solution, which we assume to be the same as water, 4.18 joules per gram degree Celsius. Delta T is the difference in temperature, which is 30.2 minus 24.0, which is equal to 6.2 degrees Celsius. The amount of heat absorbed by the solution mixture is therefore Q of solution equal to 2,590 joules. Since the solution absorbed 2,590 joules, the reaction must have given off that same amount of 2,590 joules, or 2.59 kilojoules. This is an exothermic reaction, so Q of reaction is equal to negative 2.59 kilojoules. Therefore, the negative sign indicates that the energy is released. But our value is only for this specific experiment, and we chemists report heats of reaction on a per mole basis. Hydroquinone and hydrogen peroxide have the same concentrations and volumes. So, they have the same number of moles, which are 0.0500 liters times 0.250 molar equals 0.0125 moles. In this reaction, 1 mole of hydroquinone reacts with 1 mole of hydrogen peroxide. So on a per mole basis, the heat of reaction, negative 2.59 kilojoules per 0.0125 moles, which equals negative 207 kilojoules per mole. I like this kind of calculation a lot, but most of all, I like that this reaction takes place in the belly of a beetle. So now you know about enthalpy of reactions.